Hey, it's Mr. A here. We're going to work on some geometry remastery for classifying shapes. So the first thing that we need to do is first figure out, well, how do we organize these shapes? Because they all are shapes, but there is what's called a hierarchy, which means there's really specific shapes that have to have very set amount of details and characteristics, and there's also very least specific shapes, meaning they don't really have a lot of details and the shape can look a lot of different ways. So we always put the least specific at the top, and we always put the most specific down at the bottom. So let's start with the least specific first. Well, let's kind of group these together. So I noticed that these all have 4 sides, and I noticed that these 2 don't. Okay, so I'm going to assume that these shapes are a little bit more specific since they have 4 sides, and these ones, well, this one has 2-ish sides, or rounded side. This one has a bunch of sides. So plane figure and polygon. What we know about a plane figure is it's a 2D shape. It's flat, it's 2-dimensional, it has closed endpoints, and it's flat. That's all that it needs. Because notice this rounded edge, whereas a polygon cannot have rounded edges. So I'm going to go ahead and put my plane figure at the top. That's my least specific, because it only needs 2 things: flatness and connectedness. That's it. So then I know that polygon's going to go next, because polygons can have multiple numbers of sides: 3, 4, 5, 7, 90 million sides, however many sides. But a polygon has to be flat, like a plane figure, it has to be closed. But what makes it a little more specific is that it has to have straight sides, whereas a plane figure, a 2D shape, does not. So far, least specific and a little bit more specific. But a polygon is always a plane figure because it's right underneath it. Okay, so now we look at these shapes here. Well, I noticed that there's some of them have specific angles. I noticed that, a couple of them have 1 pair of parallel sides, a couple of them have 2 pairs of parallel sides, and then this one's all by itself. B is actually a quadrilateral. It just has 4 sides, and that's all that it needs to be. The sides can be angled, the sides can have parallel lines, or it can just have no parallel lines at all, like this one. So quadrilateral is the next least specific because it's flat, it's closed, it has straight edges, and it has 4 sides. A quadrilateral is always a polygon, and a quadrilateral is always a plane figure. But a polygon's not always a quadrilateral, which why it is above it. It's less specific. Okay, so now that I've got these 5 shapes left, let's look at parallel sides, because they all have 4 sides, right? And this one didn't have any pairs of parallel sides. So if I look at these ones, I notice that these only have 1 pair of parallel sides. These top lines are parallel. They're never going to meet. These other lines are going to intersect at some point. These have 2 pairs, both the tops and the sides. This parallelogram has 2 pairs. This rectangle has 2. So I'm going to set these to the side. I'm going to look at these 2. These are what we know as trapezoids. Trapezoids' definition are 4-sided shape, at least 1 pair of parallel sides. These ones have just 1. As well as it's closed and it's flat and straight sides, okay? But these are 2 different trapezoids. I notice tick marks on this A one, whereas I don't see any tick marks on the C one. I notice that these angles are congruent and these sides are congruent. This doesn't have any congruent sides and these angles are different. This is just a regular old trapezoid. There's nothing specific about it. So it's going to go underneath a quadrilateral. A little more specifically, still 1 pair of parallel sides, quadrilateral, it's an isosceles trapezoid. Isosceles, we know, means 2 of the same, and it has 2 of the side lengths that are the same and 2 base angles that are the same or congruent. So far, an isosceles trapezoid is always a trapezoid, but a trapezoid is not always isosceles. So that's how I know that it goes above it. It's less specific. So I've got plane figure, I've got polygon, I've got quadrilateral, I've got trapezoid, isosceles, and I've got these 3 left. Well, now they all have 2 pairs of parallel sides, which is more specific than a trapezoid, but some of them have right angles and some of them do not. So I'm going to put a parallelogram up here because parallelogram doesn't have to have any sort of right angles. The only thing that makes it more specific than a trapezoid is that it has 2 pairs of parallel sides. A parallelogram is always a trapezoid because trapezoids have to have at least 1 pair. So that leaves square and rectangle. Well, we should know that a square has to have all equal sides, and a rectangle only has to have opposite sides or equal. They both have to have 90-degree angles. They both have to have 2 pairs of parallel lines. So that means that a square is more specific since that it has to have all equal sides. So when I look at these, right, I understand that plane figure is the least specific. A polygon is a little more because it has straight edges and it's always a plane figure. A quadrilateral is always a polygon. A trapezoid is always a quadrilateral, so on and so forth, to square being the most specific. So if we can understand this order, everything's going to make a lot more sense. Let's take a look at one of the questions from the Mastery. We're not going to do all of these, but let's just kind of see what these mean. I see 4 groups of shapes, and I see 4 completely different hierarchies. So what we have to remember is that anytime that something is underneath something, it's always that shape as well. So for example, these 3 should be completely different because none of them are underneath each other, whereas these 3 all need to be connected. And this one, these 2 are connected, but these 2 are different, and same here. These 3 are all this one, but this one is only this one, and it's not these 3. So I think this one sticks out the most. 3 completely different shapes. So if I take a look here at my options, I notice polygon, triangles, triangles, triangles. Well, those are all triangles, and I know that a triangle is always a polygon, and an acute triangle is always a triangle and a polygon, so these are pretty connected. Triangle, isosceles, scalene, equilateral. Well, those all sound pretty different, but I know that equilateral is always scalene. Equilateral is always isosceles because isosceles at least 2 equal sides and equilateral have 3. So that one can't be it. Quad, trap, parallelogram, rectangle. Well, those are all 4-sided shapes. Pairs of parallel lines, those sound connected. Polygon, quad, tri, pent. Ooh, 4-sided shape, 3-sided shape, 5-sided shape. A pentagon's never a triangle is never a pentagon. That means that this one has to go here, right? Because they're all different. These are not connected, so they can't be here because if a triangle is underneath a pentagon, that means a triangle is always a pentagon. But we know that that's not true. So then if I look at this one, these ones all sounded similar, right? Quad, trap, parallelogram, rectangle. Well, quadrilateral, and then a parallelogram, trapezoid, right? Because I forgot about that little. Remember, trapezoid is at least 1 pair of parallel lines. Parallelogram has 2 pairs, and the rectangle also has 2 pairs. So I know that this one's going to go here because these are all connected. So then that leaves my triangle ones. This one is showing that these 2 are connected but different. Well, if we remember anything over here that I said, equilateral is always isosceles, right? Because isosceles is that at least 2 congruent sides, and an equilateral has 3, which means it's always going to be at least 2. So that means this one goes here, so then my acute obtuse has to go down here, which makes sense because a polygon triangle, a triangle is always a polygon, and acute and obtuse are always different, okay? So when you get one like this, really just think about, if this thing is underneath it, it's always that thing. So when I'm doing these flowcharts, I have to think, if I'm putting a pentagon underneath a triangle, I'm saying a pentagon's always a triangle, but I know that's not true. So really take your time and think those through. Last question that we're going to look at are these always, sometimes, nevers. These are tricky. So the first one says, an isosceles trapezoid is sometimes a quadrilateral. Don't let this sometimes word confuse you. Guys, a trapezoid, if we remember from our picture, is always a quadrilateral. Trapezoids have to have 4 sides. That's part of their characteristics. So this shouldn't have said sometimes. It should have said always a quadrilateral. So this one is false. It's not true. A trapezoid is sometimes a parallelogram. Well, with my definition and my hierarchy, a trapezoid is above a parallelogram, but they're still connected. So that means if it's above it, it's not always that thing, but sometimes it is, as long as they're still connected. Because we know the definition of a trapezoid is at least 1 pair of parallel sides, and a parallelogram always has 2. So this one, yes, is true. It is sometimes a parallelogram. A quadrilateral is always a square. Well, this is a quadrilateral. This is a quadrilateral. So therefore, those aren't squares, but they're quadrilaterals. So it's always a square? No. Sometimes, but not always. So that one's false. A rectangle is never a square. Okay, don't let this one confuse you. Like we said with the trapezoid and the parallelogram, if something is on top of the other, as long as they're connected, they still share most of their qualities. So even though we don't usually call this, right? We don't usually call this a square. Sometimes a rectangle is a square because what do we know about a square? Opposite sides are equal. Well, rectangles have opposite sides are equal. Squares just happen to have all of them equal. 490-degree angles, 490-degree angles. Two pairs of parallel sides, two pairs of parallel sides. So a rectangle's never a square? Sometimes it is a square, which I know is mind-blowing, right? But we have to really think about what are the qualities of a square and what are the qualities of a rectangle. The last one here, a parallelogram is always a trapezoid. Well, parallelogram is underneath a trapezoid. Square is underneath rectangle. So if we know that something is underneath something, it's always the thing above it. A rectangle is sometimes a square, but a square is always a rectangle because it's underneath it. So that means a parallelogram is under a trapezoid. It's always going to be a trapezoid. So this one actually is true. These trapezoid ones are tricky, I know, but we have to know about the hierarchy. If something is on top of something else, it can sometimes be the thing below it. If something is below something else, it's always going to be that thing. Really think about these always, sometimes, nevers. 3 of these words were wrong, right? If those words were changed, it would have been true. But since those words were all wrong, they were all 3 false. So pay really close attention. All right, I know you've got this. You're going to do great. Remastery is an okay thing. You're just reworking a standard. If something didn't make sense, ask me. Google it. YouTube it. Don't just stop this video and guess on the questions. Really take this time to remaster. I know you can do this.